Hello everyone again. Now we'll solve fifth equation. Let's take another color, green. Fifth equation. We have some jar containing of 200 grams of solid candle wax. Its mass is 0.2 kilogram, yes, of a candle. It and says that here heat that the plate that supplies heat energy to the wax at the rate of Q over T equals to 22 joule over second. It's given. It's power, actually. The wax temperature is measured every 30 seconds, and here we should, whereas what is the specific heat of the solid wax? C wax, let's say. And as a melting point, the melting, and the wax heat of fusion, latent heat of fusion. Okay, let's find, here we have a graph, a table, and we should work with this table. First of all, let's find the specific heat capacity, specific heat of the solid wax. How we'll find it? We take, we can take, if we look to the table, we can see that it will remain at 70.45 Celsius, around of 460 seconds. It's actually, I think, melting point. Yes, it's actual melting point, and we can take that T melting equals to 70.4. But actually it can be 70.5 or 70.6. Let's take 70.4 Celsius. That's the melting point of the wax. We found it by graph, by table. And how we will measure the specific heat? Let's take from 0 time to 120 seconds. T1 equals to 0 seconds, T2 is 120 seconds. And here also temperatures, T1 is 20 Celsius and T2 is 64.7 Celsius. That's given everything. How we will find it? We will find by this power Q over T equals to, Q is which energy which was done here by while heating this wax around all this 120 seconds. It will be T2 minus T1. No, Q will be MC delta T over T2 minus T1. So M is 0.2, C is not given, delta T is 64.7 minus 20 over T2 is minus T1 is actually 120 seconds. It's equals to 2020 joule per second. And here we can find C. C equals to, if we calculate it, everything, well, I actually get 2,953. I forgot the joule, kilogram, Celsius, yes, kilogram, Celsius. That's our specific heat. So we found it. Let's find. We also found the melting point. Yes, it's actually around of this temperature, and the wax heat of fusion, latent heat of fusion. How will we find it? We will take the period when it was melting, and what we don't know at what time did it start, because we just know that it was melting at 150, and from 150 to 300. But what we will do? We'll just we will just find what we'll find? Let's take, actually I didn't, we can take only 30 seconds, yes. So let's try, let's take it only 30 seconds, yes. Because it's not important to take all the melting period, yes. Yes. And let's take that it let's take from, for example, 200 some 30 seconds, and it is 30 seconds. It will melt. It will be melting, and we'll find later heat fusion. Q over T equals to 220. Q is ml over T equals to 220. L equals to am I doing it right? 220. And Q equals to 50. Oh no, we should find first of all the Q. We don't know the Q. Oh yes. What? Yes, we don't know the Q. Sorry. First of all, we should find the Q, and we can take only. We should take all this the period of time. And how I find this time? First of all, we know that the melting point is 70.4, and initial is at 20. The initial is at 20. And I use this formula, Q over T equals to 2020, and Q is a MC delta T over time, and 2020. I here found the time, at what time does it start to melt? And I found that T equals to, if you will calculate this everything, delta T is 70.4 minus 20, C is, we found, M is 0.2, and T will equal to, I found that it says, how much? 135 seconds, 135 seconds. At this second, it will start to melt. And by the table, we'll take that, we don't know at what time it will stop to melt, but actually it's around of 300 and 330. And I actually took the middle of this number. It means that T1 is 135, T2 will be, if we will take the middle, it will be 315 seconds. And we shall find the Q, which is the Q, the heat of, the Q of fusion, the heat which is used to melt this wax. Q over, if T1 minus T2 minus T1 equals to 220, and here Q equals to 33 kilojoules, and we know QF that equals to ML, and L equals to 33 power of 10^3 over mass is 0.2, and we find that heat of fusion equals to 1.98 multiplied by 10 to the power of 5. That's our answer, joule over kilogram. Oof.